Okay, let's solve this equation. The idea is you want to have an equation that just has tan x on one side. So if we're going to isolate this, we're going to have to subtract root 3 from both sides or move this over there. So this starts off simple. All right. Now your job is to find what angles on the unit circle. They want angles. X is the angle, not the x coordinate, but the angle that falls between 0 and 2 pi. So where is the tangent negative root 3 on the entire one way around the unit circle? Where is that happening? Okay, so tan, let's break this down, is sine over cosine. And you know now sine of an angle is really the y coordinate and cosine is the x. So we're saying that this is, first of all, we're saying it's negative. Okay, so we're really got to focus on this quadrant and that quadrant. And we're also saying that because this is a little bit more than 1.7 something, it's greater than 1, the y is bigger than the x. You could say like it's top heavy. So where in this quadrant is the y coordinate kind of bigger than the x coordinate? It's definitely going to be down there. Of your three choices, this is the one with the biggest y relative to the x, right? And so this is the x angle. This is kind of what we're solving for right there. And its cousin, which has the same characteristics, a larger y versus a smaller x, is right over here. Okay, these two spots. Now here's my shortcut for naming that angle in radians, right? If it's 2 pi, 0 to 2 pi, we got to talk radians, not degrees. The stops along the circle that are closer to the y-axis, these are your thirds. These have 3 in the bottom of the fraction, okay? And then you're just counting how many thirds did it take from here to get there. 1, 2. 2/3 answer. I keep going. 3/3, 3/3 is 1 pi. 4/3, 5/3. So our two answers are 2/3 pi and 5/3 pi. X is one of those. Now let's solve for this. We're going to solve for cotan of x. Got to divide by both sides by root 3. So we're getting cotan of x is 3 over root 3. Okay, if we want to rationalize this denominator, this becomes a 3, that becomes 3 over, but that cancels out, so you're left with just a root 3 on top. And this, just like we saw above, is about 1.7. That means it's bigger than 1. That means the top value is larger than the bottom value. Now, what is cotan x? Okay, again, this is the angle, not the x coordinate, but cotan is defined as cosine over sine or x coordinate over y. So this has got to be the bigger one. Okay, so let's look on the circle and see where that is the case. Where is x bigger than y and has this ratio? So I hope you recognize this is one of the 3 values among these common angles. X is bigger than y here, and by the way, it's also positive. So we're looking at this quadrant and this quadrant. And x is bigger than y here as well. Just prove it to you. That's x, that's y. That's x, that's y. Now, we got to name these angles. And just like that other trick I told you before, the common stops on the unit circle that are closer to the x-axis, these are your sixths. 6 in the denominator, fraction with 6. So let me illustrate. Here's 1/6, so this is going to be 1/6 pi. 2, 3, 4, 5. This is 5/6. That's 6/6, because that's a whole pi. Why didn't we stop here and call this 2/6? Well, because 2/6 is better known as 1/3. 4/6 is better known as 2/3. So it's not like they can not have a denominator of 6. We just go with the lowest common denominator, which is 3 for these guys and these guys. But the ones that are closer to here, we say 6. So 1/6 pi, and this is 7/6 pi, because we cross the 6/6, we go another sixth. So those are two answers, 1/6 pi and 7. X can be either of those. Okay, let's solve this equation. Now, instead of just having cosine x, we got cosine squared x. No matter. We're still going to isolate that one function first before figuring out what our angles could possibly be. And so what I'm going to start with is get rid of this. Move that over. 2 cosine squared x equals 1. Divide both sides by 2. Cosine squared x equals 1/2. Now, you can't just now turn to the unit circle and figure stuff out yet, because this says cos squared. What you need is just a plain trig function. So how do we solve that? Take the square root of it. Square root and square cancel out. So you got cos x equals square root of this, square root of that. And you get 1 over square root of 2. Now, denominators that are irrational like this need to be rationalized by doing that trick. That ends up being root 2 over 2. This should look pretty familiar to you. Cosine of x equals root 2 over 2. Where is that happening? This is the middle of the 3 common values for sine and cosine. Oops. So we know that's going to happen here. And remember, we're solving an equation. That means any angle between 0 and 2 pi is fair game for giving us an answer, a solution to the equation. So here's one, and here's the other one, right? Because they're both positive values of this, okay? So name these two angles, and those are our solutions. First is pi over 4, and then I'm going to count fourths. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and 7/4 pi. X is one of those. Now we're solving a trickier equation where you see our trig function in two places, okay? So what we're going to do is think about solving for this as if, and I'm just going to do a quick substitution because you might see it better this way, okay? This is a quadratic. Up till now, well, the one before is also quadratic. But here's, when you're solving for x, you have to kind of recognize that when you have x squared and you're solving for x, you're going to have to do something a little bit different. You're not just isolating the x, and furthermore, you have another x term. You're not isolating the x on one side. You can't combine these two, right? They're not like. So what you're going to want to do is factor. This goes back to the very first thing we practiced at the beginning of the year, which is solving by factoring. The GCF is clearly 4 because they both have 4 and an x. Okay, so backfill this and we get this equals 0. So I know what x is. X is whatever makes this 0 and whatever makes this 0, because these two are multiplying. So we're going to set up an equation that says 4x equals 0 and x plus 1 equals 0. Divide both sides by 4, you're getting x equals 0. And this is obviously x equals -1. But what was x? What was our substitution right from the get-go? It was this, right? We swapped this out for an x squared. So we meant sine of theta is x. So let's swap it back. Swap it back. Okay, so now we have our instructions. Go find me the theta where the sine is 0. Okay, meaning the y coordinate on the circle is 0, where the y is -1. Okay, so here, y is 0 right here, y is 0 right here. We took care of that. 2 answers to this. 1, 2. Where is the y coordinate -1? In other words, where is sine of theta -1? Only one place, right here. So we have 3 answers. 3 answers. 3 solutions. X equals 0, that's right there. Pi, that's right there. And 3 pi over 2, right there. 3 answers. 3 solutions. Okay, next, another kind of solving question. And when they get more complicated, it might be helpful for you to swap out this again for x squared and just x, meaning sine theta swap with x. So this ends up being 2x squared plus x minus 1 equals 0. Solve. We're solving for theta, but temporarily let's solve for x. Then we'll swap the x out with sine theta and then see what we have to do. If you're going to solve for x in this quadratic, you know you're going to have to, it's a trinomial. It has the classic x squared, plain x, number kind of format. So I think we're going to want to factor using the x method and get something like this. Okay, this is what we're looking for. And we're going to set this to 0, set that to 0. Okay, so this is a tricky factoring kind of situation where we have an a and a c value. We've got to multiply those and put them up top like that. We've got a middle value of 1, since the b is 1. And we're going to solve this x method. We've got to multiply to this, add to that. If you remember, thinking -2 and +1. Multiplies up, adds up. This is not your answer. Got to remember this, our factoring strategies. This is not your answer because x times x certainly does not make 2x squared. The slip and slide method is what I think I taught last, although there's more than one method. You take this offending a value, put it under there, put it under there. If this resolves to a whole number, you go for it. If this is unsimplifiable, you take the 2, slip it in front of that x. Okay, so this is our answer. And it's always, even, I've been doing this for years, but it's worth checking, worth doing a quick FOIL, it's worth it. 2x times x, looks good. -2, +1, resolves to, oh, there, that's a good reason why you should check. That makes a -1, -2 and +1. I switched the signs. You should have caught me. This should be +2. This should be +2. That should end up positive. This is negative. That's how +2 and -1 add to +1. This should be negative. just proved my own message. You should always FOIL to make sure that your factoring came out right. And now I think it does. And final FOIL, +1 times -1 does make this. Okay, so here are two binomials. I'm very confident. X plus 1, 2x minus 1. Now, let's swap back. Oh, no, let's do this first. Let's set up our equations. That's got to equal 0. That's got to equal 0, which means that x has to be -1, which means x has to be a half, just plain half. Okay, and I'm going to actually use my eraser and swap back. Okay, because what we're truly solving for is sine theta. And then even further, we're solving for theta. I mean, that's really what we're solving for. Okay, these are two conditions. So let's go to the unit circle now that we have single trig function and some values that we are looking for where they are true. Sine of theta is -1. Because remember, this is our y coordinate. That's our y coordinate. Okay, only one spot. That's it. Okay, one solution right there. The other solution, sine of theta equals a half. We're talking about just a small rise from here to +1 half, these two. Okay, so I'm going to name the angles. Pi over 6, 5 pi over 6. And then by halves, we're traveling half, 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 3 halves. 3 pi over 2. Okay, 1, 2, 3 solutions. Last example, add 3 to both sides. Divide both sides by 3. Square root of both sides. Rationalize. Okay. Where is this true? We're done, right? We've single trig function, value on the other side. Where is that true? This is smaller than this. This is about 1.7. Okay. So we're looking for where, remember, y is on top and the x coordinate is on the bottom. Where is y smaller than x? And by the way, it's positive. Y is smaller than x here. And this is where y and x are negative, so we have to look over here. This is why Delta Math has you do those diagonal lines when you're identifying the tan or the angle where tan is some value. 2 spots, pi over 6, 7 pi over 6. Or theta. Theta is one of those.